A deep dive into the ExpSineSquared kernel in scikit-learn's Gaussian process regression. The ExpSineSquared kernel, also known as the periodic kernel, is a powerful tool within scikit-learn's Gaussian process GP framework for modeling data exhibiting periodic behavior. It combines the flexibility of the standard squared exponential kernel RBF with the ability to capture periodic patterns. 1. Mathematical formulation. The ExpSineSquared kernel has the following mathematical form: kx1, x2 xp-12 by 1 x2 length scale 2 cos 2 pi x1 x2 period, where x1, x2 two input data points scalar or vector depending on the dimensionality of the problem. Length scale controls the smoothness and overall width of the kernel function. Similar to the RBF kernel, a larger length scale creates smoother functions, while a smaller length scale leads to more localized behavior. Period determines the periodicity of the function. A smaller period leads to more rapid oscillations, while a larger period creates broader cycles. 2. Interpreting the components. Squared exponential RBF component. The first part of the kernel, xp-12 by 1 x2 length scale 2, is the familiar RBF kernel. It captures the underlying smoothness of the function and decays exponentially as the distance between x1 and x2 increases. Cosine component. The cos 2 pi x1 x2 period term introduces the periodicity. It oscillates with a frequency determined by the period parameter. 3. Benefits of using the ExpSineSquared kernel. Modeling periodic data. The kernel allows GP models to capture periodic trends in the data, making it suitable for applications like time series analysis, where seasonal or cyclical patterns are often observed. Flexibility. The parameters length scale and period offer a high degree of flexibility in adjusting the shape and frequency of the periodic oscillations. Smoothness. The combination with the RBF kernel ensures the resulting GP model remains smooth and continuous, even while exhibiting periodic behavior. 4. Example use cases. Time series forecasting. Predicting future values of a time series, especially those with seasonal patterns, e.g., monthly sales data with annual cycles. Astronomical data analysis. Modeling periodic celestial phenomena like star brightness variations. Modeling physical systems. Describing oscillating systems with periodic properties, like the motion of a pendulum or wave propagation. 5. Implementation in scikit-learn. The ExpSineSquared kernel is available as a predefined kernel in scikit-learn from sklearn, Gaussian process, kernels import ExpSineSquared. It is used with the Gaussian process regressor or Gaussian process classifier classes to define the GP model. The length scale and period parameters can be set either during kernel instantiation or by optimizing them using the fit method. 6. Advanced considerations. Kernel hyperparameter optimization. Finding the optimal values for length scale and period is crucial for accurate modeling. Techniques like grid search or Bayesian optimization can be employed to achieve this. Multidimensional data. The ExpSineSquared kernel can be applied to multidimensional input data, but the periodicity applies only along the dimensions specified in the period parameter. Combining kernels for complex data with multiple periodicities and other characteristics. Combining the ExpSineSquared kernel with other kernel types, such as RBF or Matern, can be beneficial. 7. Limitations. Single periodicity. The ExpSineSquared kernel is designed for modeling a single dominant periodic component. For data with multiple periodicities, More sophisticated kernels or kernel combinations might be needed. Assumptions: the kernel assumes a smooth and continuous function, which might not be appropriate for all datasets. Computational complexity: evaluating the kernel can be computationally expensive, especially for large datasets and high-dimensional inputs. In summary, the ExpSineSquared kernel is a valuable tool for modeling periodic data with scikit-learn's Gaussian process framework. Its ability to combine the smoothness of the RBF kernel with periodic oscillations makes it adaptable to various applications, especially in time series analysis and modeling systems with periodic behavior. This detailed explanation should provide a comprehensive understanding of the ExpSineSquared kernel and its capabilities. Remember to adapt the specific parameters and kernel combination based on the specific data and application requirements.